All right, this is problem 11.3.7, and we have the width of a rectangular parking lot is 53 feet less than its length. We want to determine the dimensions of the parking lot if it measures 240 feet diagonally. So the first thing we should do is give ourselves a picture. So we are talking about a rectangular parking lot, and they tell us some information here. So the width, actually let's look at the diagonal first. So they tell us that the diagonal is 240 feet. And then they also tell us that the width of the rectangular parking lot is 53 feet less than its length. And so I'm going to go ahead and just let x here be the length. And if I do that on my picture, this distance from here to here would be x. And if we're talking about the width, which is this distance right here, being 53 feet less than that, then that would be represented as x minus 53. Okay, so hopefully we can see here that we have a right triangle, and I'll pull this off and make it a little bigger so you can just see the triangle itself. So this side, 240 feet, this is x, and this is x minus 53. Okay, so anytime we're trying to find the sides of a right triangle, then we know we can use the Pythagorean theorem. And that theorem here, a squared plus b squared is equal to c squared. A and b are the legs of the triangle, and the legs here are the two sides that come and join this right angle. And then the c is our hypotenuse, and the hypotenuse is always directly across from the right angle there. Okay. All right, so what we're going to do is we're going to plug these in. Oh, I should have specified here. The legs are interchangeable, but I'm just going to go ahead and call this one A and this one B. Okay, so let's go ahead and plug these values in to our Pythagorean theorem, and we're going to need to solve it. So, okay, so we're looking at x squared plus x minus 53 squared, and that's equal to 240 squared. Okay, so in other words, I'm plugging in x for the a, I'm plugging in x minus 53 as a quantity for the b, so the whole quantity is getting squared, that's why I have those parentheses there, and then 240 for the c. Okay, so we're trying to solve this, so the first thing that we want to do, go ahead and FOIL this out. So this, if I write it in the expanded form, x minus 53 times x minus 53, we're going to FOIL that out. 240 squared is 57,600. Okay, so let's go ahead and do this multiplication. We're looking at first is x squared, the outside's minus 53x, inside minus 53x, and the last there is 53 times 53, a positive 2809, and that's equal to our 57,000 number. Okay, so we're continuing to solve for x. We're probably going to need to use the quadratic formula in this problem. So let's collect like terms. I see 2x squared minus 106x and plus 2809. And to use the quadratic, we need to have this set to 0. So let's go ahead and bring that 57,600 number over to the other side. So we have 2x squared minus 106x, and this will be a negative 54,791. Okay, well, this probably doesn't factor, and even if it did, I wouldn't have any clue what numbers to choose here. This is just such a large number, so I think the quadratic formula is going to be the most effective way to solve this from here. So let's go ahead and identify our a in the Pythagorean theorem formula is 2, coefficient of the x squared. B in our formula is negative 106, and c is negative 54,791. Okay, remember your Pythagorean theorem is this. negative b plus or minus square root of b squared minus 4ac all over 2a. Okay, so we're going to plug these pieces in here. So we're looking at the opposite of b, and b is a negative number there, so we have the opposite of negative 106 plus or minus b squared, so negative 106 squared, minus 4 times a is 2, and c is our negative 54,000 number there, kind of running out of room, and all over 2 times 2. Okay, so we need to simplify that further. And so just move that up. So we are looking at x equals a positive 106 plus or minus the square root of 106 squared is 11,236. And then we're going to have, whoops, how did that get crooked? Okay. And then right here, this is going to be a plus sign because we have two negatives. So we have 4 times 2 times the 54,791. So I get this really big number here. And this is all over 4. Okay. So let's go ahead and add on the inside of the radical. And when we do that, we get 449,564 all over 4. Okay, now we need to simplify this. This is not a perfect square, but it does have a 4 in it, that it is divisible by 4. So I'm gonna go ahead and rewrite this as 106 plus or minus the square root of 4 times the 112,391. And the reason for that is I can now bring that square root of 4 out as a 2. They did ask in this problem, my math lab asked us to leave the answer in the exact form and leave it simplified. So that's what I'm doing right now, is just simplifying it. So the square root of 4, just this piece, comes out as a 2. We're left with that number. Both of these numbers are divisible by 2, and so we need to reduce this. So if we reduce everything by 2, we're going to get 53 plus or minus. This 2 will go away, and the denominator will reduce to a 2. Okay. Now, the negative here makes no sense because we are talking about an application problem. It's a length and width of a parking lot, and the negative will give us a negative number, and a negative width or length makes no sense. So we would eliminate that. X here is actually our length, and that's the way we had that defined. And so the exact answer for our length is this right here. Okay, so that would be our expression for the length. And then the width, based on what we had defined as our picture, how this problem was defined, the width is x minus 53. So to calculate the width, we need to actually subtract 53 from this number right here. Okay, so that's going to look like this. So that'll be 53 plus, so we're looking for the width now. 53 plus the 112,391 over 2, and then we need to subtract 53. So this is x, and this is our minus 53, and we've just plugged this in for x. Okay. We need to get a common denominator here, so I'm going to multiply by 2 over 2. So this is 53, this whole thing. This is minus 106 over 2. So now that we have common denominators, we can bring the numerators together, and the portions of the numerators that are alike are those two portions. When I add those, I'll get a negative 53. This is still a positive number because that overall, it's a positive number because this radical is going to be bigger than that negative 53. So your width here would actually be represented by this. And I believe I dropped my units here. These are feet. in units. Okay, and that's it for this problem.